Just real quick, this is code for Msp430g2553 talking to an MX7705 ADC. It uses SPI, and it also uses a hardware interrupt. So I put this into in the code. I eventually put this into continuous conversion, and then the conversions are told when it's ready by the data ready hard interrupt to port 1 of the MSP. And going down the code further, I include the files. I need to have dummy data. The dummy is ignorable when you do the first read, because you're basically reading nonsense data the first, because it's simultaneous. But then the next one will be real data, so the character data 1 and then character data 2 will be the 2 bytes of the 16-bit data. Here's where we set it up. 8 megahertz clock. I think I divide it down by 2 eventually. And then set up the SPI bus, selecting the low on line 46 and 47. And then as we go down lower in the code, also I clear, at line 55, I clear, I put chip select low and just keep it low. I'm ignoring it basically. I could probably just tie it on the board low. So I put chip select low, and then I send some command data. So the first one I send a command, it says write to the command register of the A to D, and it just basically says channel 1, and then that the next operation will be a write to the clock register. I set the clock register up. And then number 62, I send to the command register, that's channel 1 again, and then I write that the next operation will be a read register. And then next one I go down line 63, and that basically puts it into autocal mode, and then it comes right out to regular continuous conversion mode. And every about 20 milliseconds you'll get a quick conversion, and it takes about 100 microseconds or so, or it's much shorter. And then it sits there and waits for the data ready. Once it goes into continuous conversion, and the data ready line will go down low for brief periods of time, and I want to basically read data each time it does a conversion. So I'm going to compile this and run it. And set up so I can look at the registers. I'm going to look at the register info. I run it to a breakpoint, and then I'm going to single step it down. I just break it right after I set up the MSP. Here's where I set up the A to D. So I'm going to go single step it. First command, second command. Let me see. And once I go into this mode, right after I come in there, I go into continuous conversion mode. If we look at the scope, the top trace is the data ready. And if I change the time base, I don't know if you can see it, if I increase the time base, you'll see you get those little spikes every 20 milliseconds. So when it's low, data's ready. When it goes high, it's converting, and then it goes back low again. So you got that much time. The trick is to have the SPI data just have a real quick bleep after the spikes, each spike, and you'll see what happens. So I'm going to single step it. Actually, I'm going to jump right into the interrupt routine. But first, let me explain the interrupt routine. In the interrupt routine, basically once it gets, when data is ready, it writes, it says, hey, the next thing's going to be, it writes to the command register of the A to D, says, hey, the next data is going to be a read. You read it, but it's just going to be fake data because the data hasn't been converted yet properly. And then the next 2 bytes of data will be the data. So it'll just continually, after each conversion is done, it'll read the data real quick and include those 3 steps. So we'll jump into, we'll just start running it, and then look at the scope again, and you can see the bleeps are reversed. That's just the inherent, because that says when the conversion is done. This actually inserts and say, I don't want to be ready until the next bleep. So that's what the wave looks like. Kind of inverts it. It's kind of confusing, and it confused me when I was trying to do the code. but it's doing what it's supposed to. So if I expand it, and also that rise time got me worried, but it's ignorable in this case. And you can see now, so data ready goes low. You can see that this is the command that says, hey, the next function is going to be a read. And then you send two more dummy commands, which are 0, 0. And what you do is get back on those commands is 0, 0, because you have basically, I have 0 at the input of the A to D. I can actually turn on the input. And again, remind you, this basically is going to be FF dummy data. And then this is the actual data, these 2 bytes. And if I actually put voltage at the input, you can see that changing. So those are the upper and lower bytes changing. And then you could take that and come up with an actual value. That's it. Thank you.